Hello students, welcome to physics class. Today we discuss vector product or cross product of two vectors. Let us see what you mean by vector or cross product of two vectors. The vector or cross product of two vectors is defined as the vector whose magnitude is equal to the product of magnitude of two vectors and sine of angle between them, and whose direction is perpendicular to the plane of the two vectors and is given by right hand rule. That is, if A and B are two vectors in this plane, in this diagram, vector A and vector B are two vectors in the plane, in this plane, and theta is the angle between them. Then the vector or cross product of this vector A and B is defined as the is equal to the product of magnitude of two vectors, that is A cross B is equal to the magnitude of vector A into magnitude of vector B into the sine of angle between them. The theta is the angle between these two vector A and B, that is A into B into sine theta. Into a unit vector is given, that is this unit vector n is a vector in the direction of A cross B. So A cross B is a vector quantity. We are taking the product of vector A and B, we are getting another vector, that is the direction of that vector is in the direction of this unit vector n. And the direction of this A cross B can be predicted by the right hand thumb rule or right hand screw rule. Let us see what is right hand thumb rule. How to find the direction of A cross B by using right hand thumb rule. According to right hand thumb rule, if we curl the fingers of right hand in such a way that they point in the direction of rotation from A to B through the smaller angle, then the stretched thumb point in the direction of A cross B. Here in this situation, A and B are the two vectors in this plane and theta is the smallest angle between them. So to apply this right hand thumb rule, so the stretch the curl of fingers from A to B. If we are holding the curl of these fingers from A to B to the smallest angle, then the thumb point in the direction of A cross B. In this diagram, so this is the smallest angle from A to B. So keep your curl of fingers from A to B to the smallest angle, and my thumb is in the upward direction. So that's the direction of A cross B. If you are holding the right hand in such a way that the curl of fingers from A to B to the smallest angle, from A to B to the smallest angle, then the stretched thumb give the direction of A cross B. So here from A to B I holding my curl of fingers, then thumb is in the upward direction, that is perpendicular to this plane and in the upward direction. A cross B is not in this plane, it is perpendicular to the plane of A and B as in the upward directions. But if you want to find what is B cross A, so if you are finding what is B cross A, then hold the curl from B to A, that is this from B to A, the smallest angle from B to A, like this. Then my fingers, that is the thumb, come downward. So the direction of, that is the direction of B cross A is just opposite direction of A cross B. So we can say that A cross B is not equal to B cross A, but it is minus of B cross A. A cross B is equal to minus of B cross A, because this is the direction of B cross A and this is the direction of A cross B. So by using right hand thumb rule, we can predict the direction of A cross B. A cross B is a vector quantity, that's why we calling it a vector product or cross product. We can also use right hand screw rule to find the direction of A cross B. We can use the right hand screw rule to find the direction of A cross B. According to right hand screw rule, if a right hand screw is placed with its axis perpendicular to the plane of vector A and B. Imagine we are placing a right hand screw here. in the plane of A and B, perpendicular to the plane of A and B, and is rotated from A to B. Here, this is the direction of A to B. If you are finding A cross B, the direction of A cross B, place a right hand screw at this plane, perpendicular to this plane. And imagine you are rotating that right hand screw from A to B. And the direction of advance, the direction at which the screw is advanced, gives the direction of A cross B. So to find the direction of A cross B, we are placing a right hand screw here and rotate the right hand screw from A to B to the smallest angle. So you can see that it advances in this direction, in the upward direction, rotating from A to B, and it advances in the upward direction. So the direction of A cross B is in upward direction. What about B cross A? If you are placing a right hand screw here perpendicular to this plane and rotate from B to A, so it comes downward. So the direction of B cross A is in this direction, downward direction, just opposite direction of A cross B. So you can use either right hand thumb rule or right hand screw rule to find the direction of A cross B. Then some physical example for the dot cross product of two vectors. One is torque. The torque is the cross product of the position vector and the force vector. It is a cross product between the position vector and the force vector. Torque tau is equal to R cross M. And the angular momentum. Angular momentum is the cross product between the position vector and the linear momentum, R cross P. L is equal to R cross P. Vector L is equal to R cross P. And instantaneous velocity, V is equal to omega cross R. Omega cross R. So these are the some of the physical example for the cross product of two vectors. Now let us discuss some properties of vector product. The first one, vector product is anti-commutative. It means A cross B is equal to minus B cross A. We already discussed when you are finding the direction. We know that A cross B is just opposite direction of B cross A. That's why vector product is anti-commutative. The second, vector product is distributive over addition. A cross B plus C is equal to A cross B plus A cross C. That is, vector product is distributive over additions. Third one, if A and B are parallel, then A cross B is equal to magnitude of A into magnitude of B into angle between A and B. Since A and B are parallel, the angle is 0. AB sine 0 into a unit vector in the direction of A cross B. So we are getting a null vector or a 0 vector because sine 0 is 0. So A cross B, if A and B are parallel, we are getting a null vector. Fourth property, if A and B are anti-parallel, A cross B is equal to AB into sine 180. If A and B are anti-parallel, AB sine 180 into unit vector, we are getting a null vector. Fifth property, if A and A cross A is equal to A into magnitude of A into the sine of angle between them is 0, sine 0. Again, we are getting a null vector or 0 vector. A cross A is equal to 0. Then sixth one, if A and B are perpendicular, then we can write A cross B is equal to magnitude of A into magnitude of B into sine of angle between them. Since A and B are perpendicular, sine 90 into a unit vector. So we are getting AB into unit vector. AB into unit vector. So if A and B are perpendicular, we are getting A cross B is equal to AB. Then the cross product between the unit vectors, I cross I. We know that I is a unit vector along x-axis. So I cross I equal to 1 into 1, magnitude of I, 1 into 1 into sine of angle between them, sine 0. So 0. So what is I cross I equal to 0? Similarly, j cross j and k cross k are 0. I cross I, j cross j and k cross k equal to 0. And what about I cross j? I cross j, that is 1. Magnitude of I is 1. Magnitude of j equal to 1. So 1 into 1 into angle between them. You know that I is along x axis, j is along y axis. The angle between them is 90, sine 90 into a unit vector. And by right hand thumb rule, we can find the direction of I cross j is along the z axis. So the unit vector along z axis is k. So what is I cross j is equal to k. I cross j is equal to k. To find the cross product between the unit vector, to remember this, so better if you are writing this I, j and k in a cyclic circle, and if you are taking the product in anti-clockwise direction like this, anti-clockwise direction, we can write this I cross j, I cross j, I cross j is the third one, that's k. I cross j equal to k. Similarly, j cross k, j cross k is equal to the third one, that is I. And k cross I, k cross I, that is equal to j. The third one is j. So, if you are taking the cross product in anti-clockwise direction through this circle, cyclic circle, we are getting like this way, all positive. That's I cross k, sorry, I cross j is equal to k, j cross k is equal to I, k cross I is equal to j. If you are taking in anti-clockwise direction, I cross j is equal to k, j cross k is equal to I, k cross I is equal to j. Similarly, if you are taking this product through this circle in clockwise direction, like this, I cross k, what is I cross k is equal to minus j. That is k cross j is equal to third one, that is minus I. And j cross I is equal to minus k. So in this way, we can remember the cross product between the unit vector through this cyclic circle. Now let us see how to find the vector product in terms of rectangular component. Here two vector a and b given in rectangular form, that is axi, vector a equal to axi plus ayj plus azk, and vector b is equal to bxi plus byj plus bzk. Axi is the x component of a, ayj y component, and azk is the z component of a. Similarly, bxi is the x component of b, byj is the y component of b, bzk is the z component of b. So to find a cross b, the most simplest method is write a cross b in a determinant method. That is, to find a cross b, first draw two parallel line, and it's a mathematical operation. We will call it as determinant. So first write unit vector I, j, k like this in this order, I, j, k within this two line. After that, write the x component of a and b here, ax, bx. Here write the y component, ay, by. Here write the z component, az, bz. Ax, bx, ay, by, az, bz. X component, y component, and a z component. Now let us operate it. How to find the determinant I, j, k, ax, ay, az, bx, by, bz. So first write a cross b is equal to I into first, okay, take the product between this in this order, ay into bz, cross product, minus by into az, that is I into ay bz minus by az in this cross order. Okay, first this one and second minus this ay bz minus by az. And the second term is minus. The alternate terms will be plus and minus. The second term is minus, third term is positive, and the fourth term, if any fourth term is the, it will be negative, like this in the order. Okay, so minus, second term is minus j into, by taking the second term minus j, okay, minus j, you take this order, ax into bz, ax into bz, the first, this one, minus this one, okay, bx into az. The second term is automatically comes negative, minus j into ax into bz minus bx into az. This first one, ax into bz minus bx into az. The third term is positive. Once we are finding the third term, that is third term is k into that is this order. First multiply this ax into by minus second this one 2 bx into ay. This is the determinant operations. So what is a cross b is equal to I into ay bz minus by az. Ay bz minus by az. Second term is minus j into why you are taking j, take this multiplication, ax bz minus bx az, minus bx az, plus the third term, that is ax by minus bx ay. So that is a cross b. If a and b are given as a rectangular component, we can use this determinant method to find a cross b. That's all today. Thank you.